All right, so there's a few things that you have to have written down, which is x squared plus y squared equals r squared. That's one of them. And then tangent of theta equals y over x. And then another one that's often used here is sine squared theta plus cosine squared theta equals 1. These are kind of all in play here.
Mm-hmm.
So for the number 1 here, y over x is tangent of theta equals 2. And then you solve for y equals 2x. I think you're more likely to get a question like number 2. So let me snip that in. Here, oh, I'm sorry, there's a couple more. X equals r cosine theta, y equals r sine theta. So these are potentially very useful here. But the way these are used is like you can solve for cosine theta equals x over r. Sine theta is y over r. And then you can use those in an equation like this one. So it's r equals 4 x over r for cosine theta minus 4 sine theta y over r. And then to clear this r, well, let me actually rewrite this. So 4x over r minus 4y over r. If you multiply both sides by r, sometimes it gets worse before it gets better here. You get r squared equals 4x minus 4y. And we know that r squared equals x squared plus y squared. So you can substitute that in, x squared plus y squared equals 4x minus 4y. And like this is done, but it's a circle. So you're supposed to like, and this is probably where I'll stop. You're supposed to move these over and then complete the square.
Mm-hmm.
So doable, but some work. But then you go the other way, right? You go, and I think going the other way, I think going the other way is easier because you generally just substitute in for x and y.
Yeah.
That seems to be the kind of the standard thing here to do. So, I mean, I would guess you would get one forward and one backwards. One, one where you go polar to rectangular like we did, and now rectangular to polar. X equals r cosine theta, y equals r sine theta. You could also expand these. I mean, that's okay too. So like x squared minus 2x plus 1 plus y squared plus 2y plus 1 equals 2. The ones cancel with the 2. And then you have this x squared plus y squared. And then if you move some things over, you get 2x minus 2y. And now it actually looks a lot like the previous one that we're doing.
Yeah.
So the x squared plus y squared is r squared. 2 times r cosine theta minus 2 r sine theta, and then you divide both sides by r because you can only have it in terms of r and cosine, but if you can get away with solving it for just r, then you should do that. Sometimes you can't. And do you know if this is like a multiple choice, free response type question?
They usually aren't multiple choice.
Okay. So you just go until you feel like you're done. I mean,
Yeah.
there's a lot of knowledge here to be able to do these. Do them all. So like we're not doing all of them, like, but I mean, is there another one or two that you want us to look at that
Um,
maybe you
okay.
feel like could be on the test because yeah.
Can we do one like with cosecant or secant,
Sure.
like 9 or 12? Maybe
Sounds
9.
good. I'm looking at 9. 9 is weird. Why do they add in the plus pi over 6? Okay. The 9, I guess I'll grab 9. It seems to draw from a sum and difference type problem. I'll show you that here. Okay, so this is really equal to 4 over sine theta plus pi over 6.
Okay.
And there's a sine alpha plus beta formula. Do you remember that from before?
Yeah.
Yeah, so that's what's going on here. Let me find it myself because I don't remember these. Trig. I'll send it to you also as a link. So the sine alpha plus beta, that's on page 2, but it becomes sine alpha, or the first one, cosine beta plus cosine alpha sine beta. So why does that matter? Because it's going to be 4 over sine theta cosine pi over 6 plus cosine theta sine pi over 6. So pi over 6 is 30 degrees. So cosine of that is the x value root 3 over 2. And this is 1/2. And then now we can actually do something about the sine of the cosine, right? X equals r cosine theta. So cosine theta is x over r. And then y equals r sine theta. So that makes that y over r on the bottom here. And that all equals r. So now it's just, I mean, it's just a mess. I mean, it's not like, and you've essentially done it. It's like, well, how do I proceed from here? Probably, what do we want to do here? So one of the things you can do that most students aren't real comfortable with is you can actually swap diagonally with these positions, because if you divide by r, it gets on the bottom. If you multiply by this, so you get y over r root 3 over 2 plus x over r times 1/2 equals 4 over r. And if you multiply everything by r, you can see that the r's go away, which is what you wanted. So you have y root 3 plus 1/2 x equals 4. And then you can solve for y if you so desire here. Y equals 4 minus 1/2 x divided by root 3. And then you can rationalize if the instructor wanted that. 4 root 3 minus root 3 over 2 x all over 3. And a little more here. 4 root 3 over 3 minus root 3 over 6x, like that.
Okay.
Probably more than you wanted for that, but that is what's needed. I mean, if you really like hardcore algebra, that's what you've got for these.
Yeah.
I don't know, maybe I made a sign error somewhere, but because the answer is slightly different. I mean, it's got the root 3s in it, but they got different denominators. I don't know.
Okay.
Cosine, sine. Okay. We should move on to the next one unless you have strong.
Yeah, let's move on.
Okay. All right, so let's look at number 1 here, I guess, polar coordinates, plotting them. Snip. So here's a question on that second worksheet. So it's saying you're going out 3, but then you're rotating 150 degrees. So it's right there. Like the answer is that point right there.
Yeah.
And but I kind of like showing the length in the direction that it is and a little arrow. But it's totally correct. Now, is there another way? Because I assume that's what this goes to. Is there another way to get to that point? Because that's what's being asked for in questions like 5.
Yeah,
Um,
just like the negative degrees.
so you can go the counterclockwise, right? So you can actually go 3 minus 210. But there's actually other options because you can actually negate this length here. So it flips it. So if you flip it, it's sometimes easier to do the angle first, 330 degrees, and then -3, because it would be going down here, but then you flip it to go the other way.
Okay.
And then there's another way to get there is -30 degrees, -3. So what you should notice is all the angles are different. And that's true when it's not in one of the like nice positions, but
Yeah.
two of the lengths are the same and two of the lengths are the same.
Okay.
Um, so for a question like, I guess they don't do that. Grab number 4 here. I was gonna say you can actually go all the way around the unit circle, but they don't do that here. But let me grab number 4 here. We'll kind of do the same type of exercise. Okay, so where is 23 pi over 12? Well, it's like if it was 24 pi over 12, it would be 2 pi, but it's just less than that. So you're going all the way around, you're I don't know, you're right here roughly. But then it's -3. So instead of it being here, you got to go back the other direction. So it's like right there. Instead of being right, if it was 3, it would be right there. But this is -3, you flip it. Is that okay?
Mm-hmm.
All right. So then the question is, well, how else can you get there? Well, you really want to do the negative one first. So it's like, how do you get to this angle going the other direction? So that's -pi over 12. That's the one where you're just coming down
Mm-hmm.
and then flipping it. And then for the positive ones are the angles to get there and then there from the origin. So the positive ones are usually easier to do. So the positive one, you're going just short of pi, but because it's denominator of 12, you go one less than that, 11 pi over 12. Now you got to go the negative direction. It's -13 pi over 12. So there's always 4 ways to get to the same point is,
Yeah.
I guess, the reason for this problem here.
Okay. All right. So I'm good with that.
Yeah, so I would move us to 5, maybe 5 and 6, but they're just like what we did, except they don't give you the graph.
Uh-huh.
7, we should do 1 of 7 if that's okay.
Okay.
Okay, so it says to convert each pair of polar coordinates to rectangular. So x equals r cosine theta, y equals r sine theta. So you literally just put the numbers in. This is r, oops, let me do it this way, r and theta. So it's 1 cosine 5 pi over 6, which means you have to make your unit circle, 1 sine 5 pi over 6. So this is 1 times negative square root of 3 over 2. This is 1 times 1/2, I think. Yeah. So it's minus square root 3 over 2 comma 1/2 is your XY pair.
Okay.
It's much more difficult to go the other direction. These are the one I just showed you, that you want lots of those because it's just put the number into the equation and go. This one is different though. This one is more complicated. So your equations, tangent of theta equals y over x. So y over x. So tangent of theta equals 3/2 over 3 square root 3 over 2. So the 2's cancel. This 3 cancels. You get 1 over root 3, which we know rationalizes to root 3 over 3. But that doesn't help because you got to know where that is on the unit circle. And that's why these problems are so much tougher. Like you have to realize, oh, that's square root of 3 over 2. I'm sorry. It's actually 1/2. This is really 1/2 over √3/2. So which angle on the unit circle gives you that? Where the sine value is 1/2 and the cosine value is √3/2. Well, it's pi/6.
Yeah.
This point is also in quadrant 1, so that also helps you. Are you allowed to use Desmos for this, or like for the exam, or is it on paper?
Not Desmos. I can have my calculator for some of it, but if
Yeah,
it's like polar, I feel like we'll need Desmos.
well, I was going to say you could plot this and it'll show you which angle it's on also. But that's only if you have the computer.
Yeah.
So okay, you got that. Well, you still need the other part, which is x² + y² = r². A lot of students do this one first. So you square the first one, square the second one, and you should get a number. So this is 9 times 3, 27/4, plus 9/4. So notice that is nice, 36/4, which is 9. So r equals ±3. So which one is it? Well, it's depends on what angle you got. Since your angle's in the first quadrant, because the angle could have also been in the third quadrant, 7 pi/6, because they're both negative, then that would correspond with the negative number here. So again, there's like a million answers. Well, not many. There's 3 answers. The one I think your instructor is looking for is 3 pi/6, because that's in your first quadrant. But it could also be all the other ones that we talked about.
Yeah. Okay, I'm good on that. Maybe we should do the word problem, number 13,
Okay.
and then we'll move on to the next one.
Plane is detected at 285 degrees counterclockwise from north. So counterclockwise, so going this direction. So that's 90, 180, 270. So it's 15 degrees there. 3 miles. So 3 miles. Okay. And 30 seconds later, the plane is detected at 225 degrees and 2 miles. So let's see, 90. So it's there, 45 and 2 miles. Okay. Estimate the plane's speed in miles per hour. So how are you supposed to do this in your class? So speed is distance over time.
Yeah.
And we want a miles per hour. So 30 seconds is how much of an hour? So your time is 30 seconds times there's 60 seconds in 1 minute times there's 60 minutes in 1 hour. Great. So that's your time on the bottom. Your distance you have to find using some other method. So like I would find the XY pairs of each of these, but you probably can do it another way. You can actually, I would have to, I mean, there might be a shortcut here, but I think based on the previous problems, 11 and 12, you're supposed to find the XY pairs, but maybe there is a polar distance formula. How about there is? Does that sound at all familiar from class?
Yeah, I think that's
There is arc length, but that's a curve. That's a curve distance. We could also use law of cosines, because you got a 3 and you got a 2 and you got 60 degrees between them.
yeah.
I don't see distance formula.
Mm,
Okay, here it is. But see, I wonder what the angle is. Theta 1 minus theta 2. So here's the formula for it. But these are in polar coordinates. So the first one, if we were to do it in polar coordinates, we'd have to say r1 comma theta 1 is 3 comma 15 degrees. But the other one is bigger. And the reason is because they start from north and they go counterclockwise. So you have to take that into account that it's not the traditional, it's not 285 and 225, at least as far as. So then the other one you get, let's see, 90, 180, 270, 315 degrees. So it's 2 comma 315 degrees. So you could, and they do say you can change the order of these. Oh, this is law of cosines. It's interesting. Okay, so we'll just switch these. So it's 2 squared plus 3 squared minus 2 times 3, and then it's 315. It's cosine. Cosine 315 minus 15, and you get some number for that.
Okay.
But you have to know this formula. But then you have to take all of that and divide it by this 30 over 3600 to get the right units.
120 root 7 is the answer. Okay, let's move on. I don't want to get too hung up on that.
Okay. So I see the major concepts from each section. 4.7, 4.8, 6.1, 2, 3. Okay. All right, let's look at 4.7. These don't seem very useful.
No,
Um,
I can do all of 4.7, so I want to skip that. Harmonic motion. Um, let's do number 3 on 4.8.
Okay.
Those are just like the elevation, depression.
Yes. Yes. An 8-foot long piece of 2x4 wood is used to prop up a fence. If the 2x4 makes a 35-degree angle with the ground, how high above the ground is the point where the 2x4 contacts the fence? So here's the fence, here's the ground, and here's the 2x4, which is 8 feet long. And they tell you that it makes a 35-degree angle with the ground. We assume this is a right angle. So we're just asking for the height of this particular thing. So it's a right triangle. You have SOHCAHTOA, sine, cosine, and tangent. Because you have this angle opposite over hypotenuse, you could say the sine of 35 equals h over 8. So h equals 8 sine 35.
Yeah.
And you have your answer.
Okay.
So right angle trigonometry, pretty straightforward.
Mm-hmm.
Do you want us to do 4?
No, I got those down. We can
Okay.
move on to 6.1. This is all vector stuff.
Yes.
I don't know. I think, can we just go through those? I
Sure.
think we can do that pretty fast just to make sure.
Which of the following is not a factor in determining whether two vectors are equal. So vectors, what this question is really asking is, what is a vector? It has both a magnitude and a direction.
Mhm.
Okay, so obviously you need the direction and you need the magnitude. Okay. Now the location of the vector in the plane. So this is probably the hardest one. That you can actually slide vectors around. So here's a vector. You can push it up, and these are the same. You can like if it's going that direction, you can move it over here. You can go up, down, left, right. So that that is not important. Like where they are located does not matter. So this is your, this is your answer. Like they're still equal even though they've been moved around,
Yeah.
but they must have the same direction. I mean, they have to be pointing in the same direction, and their length has to be the same.
Okay. Got it.
Okay. So this thing you're sending me is I mean, I've seen this before. Maybe it's the same instructor, but it's a terrible review because it doesn't give you enough like practice problems. It's very conceptual.
Yeah, it's just like the ideas.
Yes, and it's great, but like for you as a student, I mean, have your exams ever been like this? I mean, do you have a new teacher?
Most of my exams are a lot more conceptual than they are
Okay.
like actually doing problems.
Okay. Well, then I guess this is what it is. Okay, so the velocity of an object, velocity has both magnitude and direction. So that's a check. The direction angle of a vector, I guess that's referring to theta. Um, I guess we can call this I actually don't know whether an angle is a scalar. Never even thought of that.
I feel like it would be.
It is because it's just a quantity. So since it's a number, we say it's a scalar.
Yeah.
So the horizontal component of a vector. So let's say this is your vector. It has a horizontal and a vertical component that are both vectors. So yes, it's a vector. So the product of a scalar and a vector. So here's a vector. And then let's just say you have a scalar times 2. So 2v is still a vector.
Got it.
The speed of an object in motion. So speed is a scalar because it does not, like you think of your car when you're driving, it doesn't know whether you're going north or south, forwards or backwards. It's just a number.
Mhm.
A sum of two vectors. So interestingly, if I add this vector and this vector, I get a new vector. Well, new vector, right? But if I add this one and this one, I get 0. So probably the true answer is it depends, but I think they're looking for vector here.
Yeah. Okay.
Okay,
All
now
right.
the next, you want us to do a next grouping, the 3?
Find two vectors. No. Let's move on to 6.2.
Okay.
These are such weird examples.
Yeah, I mean, is there a chapter review that you could quickly pull up for us to look at? Those are generally better, but like you said, they're more.
Yeah, let me check it out. All right, I found one. Okay, it should be coming over to you
Okay,
right now.
take a look.
Just some like vector addition problems.
Okay, yeah, well, this might be slightly more interesting to look at. Okay, two forces with magnitudes of 20 pounds and 14 pounds and an angle of 55 degrees between them are applied to an object. Find the magnitude of the resultant vector to the nearest whole number. So this is your like what we would normally do is we would break them into their x and y components, but we really don't have enough information to do that. So this
Yeah.
literally becomes a law of cosines problem where you've got 20, 14, and 55.
Mhm.
Is because you can and what maybe doesn't, why is it there? Like I mentioned, you can slide them.
Yeah. What we did
So
in class was like make it into a parallelogram and then
okay,
like so
yeah, and that works nicely if one's going that way and one's going that way.
yeah, like that.
Yeah. So I mean, you can do that. I mean, well, there's a few ways to do it. So if in this problem, let me take another attempt here. So I'll use this as the kind of the base here, and then this is going up. So if this is 55, then this is 125 degrees.
Yeah.
Okay. And so if you consider this the x direction, you need to break this into its x and y. Is that what you did, or did you do something else?
Um, okay, I'm not sure how to like explain this.
Well, this one we can break into because this right here is 55. So it's got this other x component, which we can call x equals 14 cosine 55. And then this y is y equals 14 sine 55. And then your resultant vector here is this x, which is 20 plus 14 cosine 55, the x direction. Your resultant in the y direction is just this one.
Uh-huh.
And then to find the magnitude of just the magnitude here, the magnitude of r is rx squared plus ry squared square root. So you get both of these numbers, and then you square them square root after you add them. This is kind of a complicated thing to do, but it's doable.
Yeah, they're hard.
This is the result. I mean, you get two numbers, you got to have your calculator, and in you go. But like I mentioned, you can also use law of cosines,
Mhm.
which I think is faster, but if you don't remember it, it's not faster. So
Yeah. Um, okay.
15, 16, 17 are just drawing the picture and then doing the
Yeah.
same thing.
Okay. Are there
If
any that are
if they ask for theta, theta's arctangent of ry over rx, just like you were.
can we like do one of these questions, but instead of finding the resultant, like do subtraction? You know what I mean?
Well, that would you would the only reason they would negate is if like one was bending back on the other.
Yeah.
So like if you have this vector and then this vector like that,
Uh-huh.
that would be a subtraction problem. Like let's say we knew that this was 30 degrees.
Mhm.
It still has an x component, but now it's just negative, and a y component, which is positive. So let's say this is 20 and this is 12. So your resultant in the x direction is 20 minus this x. This x is 12 cosine 30. In the y direction, it's the 12 sine 30. Is that what you meant?
Yeah.
So all it does is change the sign. So if it bends back on itself, you just undo it.
Okay.
And I just arbitrarily chose that there was 30 degrees between them.
Yeah. Okay.
And then same thing, R is same as before.
These make sense to me. It's just like a lot of work to do them.
If you take physics, this is like every problem in physics in the,
Really?
yeah, it's pretty horrible. It's really a math class. It's really a trig class with vectors and stuff.
Gosh. Glad I never took that then.
Yeah, well, maybe I get to in college. You never know.
Ugh. Okay. Let's see what else is on that worksheet. There's some like parametric curve stuff, like 6.3.
Yep.
I'm not really sure what is going on with that. Like number 1.
Yep. Let's take a look.
Okay.
Number one's kind of a question that's numerical, so you can get some things here. All right, let me snip this in. Okay, so the first there are really two separate problems here. So let's go with the first one here. So you make a table. You have a t value, you have an x value, and then you have a y value.
Yeah.
Okay. So the first thing is that you need to pick like reasonable values of t. They don't actually specify, but we're going to assume that t is greater than or equal to 0. They really need to specify that for you. So let's just make t 0. So x is t plus cosine t. So in the first one here, it's 0 plus cosine of 0, which is 1. And y is always 4. So if we were to graph that, we're to graph x and y, which is what we're used to graphing, you'd get that point right there. Now we got to be careful with the next one because you can only evaluate for certain values of cosine. So let's go like pi over 2. So pi over 2 is pretty nice. Although I guess we could go pi over 3 because pi over 3 gives you 1/2 here, but then you got an issue there. So I don't know. So that's pi over 2 plus cosine pi over 2. That's just pi over 2. And that's still 4. So here is pi over 2. Was that a little bit more than 3? Right there. But what happened in between them? So we should probably look at that now. Like in between, I mentioned, well, there's something going on there. So let's look at pi over 3. That's pi over 3 plus 1/2. So it's a little bit actually further to the right here.
Yeah.
So it's a little awkward, right? It's like, what's going on here? Well, it's almost like, she was here and then she went backwards.
Oh, okay.
Now, like what's going on at pi? So pi, cosine of pi is -1, so you get pi minus 1, still 4. So it's like she's moving and she's just moving back and forth.
Okay.
But that's because the y value is unchanged.
Got it.
But what you need to take away is like, this is how you, on the right here, this is how you determine the behavior of a parametric equation. You plug in t values, you get x and y's, and you try to, like, in a more traditional problem, you would get some sort of a thing that you could then map.
Yeah.
The second one, the only difference, the second one is that your t is negative. So like your first point is actually, yeah, your first point is here, but then you keep going down. So you get wherever you were, you're here and you're here. Like it's like you're moving kind of back and forth like that,
Mhm.
I guess. So it's a weird problem.
Yeah.
But like what you should take away is, can you evaluate each of these? And you can. You
Okay.
totally can.
All right. Um, let's do 3.
Question 3, same.
Yeah.
All right, 3A, we'll look at first. All right, consider the parametric curve, find the endpoints of this curve. That means evaluating at t equals 2 and t equals 9. So x is f of 2 and y is g of 2. And then at 9, x equals f of 9 and y equals g of 9. And there's nothing more you can do there. That is the extent of it.
Yeah.
Okay, so then part B, and this is purely symbolic. There's no like numerical answer here. Part B says consider A plus f of t and B plus g of t, where C is less than t less than d. Find the values of C and D so that the curve is a translation of the original parametric equation. Explain how this curve is affected by the values of A and B. Hint, you may want to try certain values here. So if we try the endpoints again, we get x equals A plus f of C and y equals B plus g of C. So it looks like it's x minus A equals f of C. So that's A, right? If you think of like a quadratic, that's why they say t squared.
Mhm.
And then y minus B equals g of C. So this is also B to the right. And that's
Okay.
all they're looking for. They're like, well, what happens and compared to the original? So the original is shifted A right, B right. But that's if A and B are positive, which we don't know. If
Yeah.
they're negative, it goes the other way. We actually also don't know the values of C and D. Too much unknown to like make any general claims. You'd really be better off using like a parametric Desmos to try to see what happens for different values if you
Yeah.
had access to that. Should we keep going on that one?
Um, no. Let's see. 6.4. I think we covered all that. That's just the polar stuff.
Yep.
Looking at 6.5 now. Maybe we'll do number 2. Finish it up.
These you have to graph.
Okay.
And there's no way. Okay, there is. I take that back. Your textbook probably has like if it's of this form, meaning
Mhm.
like if it's a number sine theta, it's always a circle.
Yeah.
If it's a number over sine theta, numbers cosecant theta, it's always a line. Those
Mhm.
are the kinds of things that you're looking for here. The only other way to do it is to graph and then compare your graph to this, like what is a cardioid, a dimpled limacon,
Right. Okay.
limacon.
And let's do a couple of 6.
Okay.
I just don't really understand what it's asking.
So yeah, this is where sometimes putting numbers in can help. So they're saying, let me get this down here. So let's pick let's say R is 2 and theta is 60 degrees. So
Mhm.
that is right there. You agree with that?
Yeah.
So let's just assume that's given in all these. So now they're saying, well, what is R minus theta? Well, that means it's 2 comma minus 60. Well, where is that? Oh, it's down here now. So what kind of symmetry does it have? X
Yeah.
or
Okay.
what's the change? So there's x-axis, y-axis, rotational, none, I guess. Like, and sometimes it says like take pi over 2 and subtract the angle. Well, if you pick a weird angle, you might think something is true that isn't. So you got to be careful here to pick a non-standard angle.
Okay. Got it.
This is really weird. I mean, you know what your tests are like. If none of this has been useful, go back to whatever you think would be likely to be on the exam.
Okay.
This didn't feel very helpful today.
I mean, it makes a lot more sense conceptually, which
Okay.
is what I was having issues with. Like, basically what she's looking for is that we can like understand the concepts more than just getting the answers right. So
Yeah.
yeah.
Okay. Well, I mean, you'll do the best you can, and you'll almost be done here in about a week. So,
Right, yeah. But I have my final, so I will see you very soon.
all right, sounds good. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Okay, thank you.
Have a
Bye.
good day. Bye now.